Hello, everyone. In this episode of the EU Energy Projects podcast, I'm joined by Eduard Escalona, Market Development Operator of the EU Agency for the Space Programme, and Fernando Cassola, researcher at INESC Tech, representing the BlueX project. Data from space is proving increasingly important in the way we live and work and is finding growing application in a range of use cases in the energy sector. And we will now look into some of these, and in particular the role of the Copernicus programme. I'd like to start by asking you, Eduard, what USPA is and what its role is in connecting space technology with the energy sector.
Hi, Jonathan. Thanks for having us. So USPA is, as you correctly said, EU Agency for the Space Program. We are an operational agency of the European Commission, and we have the role of having different responsibilities over the EU Space Program, which is composed by different components. But one of the main aspects is the market uptake. So it's making sure that the space sector it's well represented in Europe, and the space asset, the European space assets, which are Copernicus, as you mentioned, is the Earth observation program, and Galileo and EGNOS, that are the navigation ones, as well as the future satellite communications programs like GovSatcom and IRIS², are well used in the downstream sectors. In particular, here we are representing the energy sector.
Well, I'll come back to some of those, but why is space so critical in the EU's green transition?
So, as we know now, there is the need to do a massive deployment of renewable energy projects and to have more sources of energy. And space, and in particularly Copernicus for Earth observation, can provide lots of data that can be useful in different types of applications in the energy sector. So, for example, you can use space applications for geospatial data, which tells you the composition of the atmosphere, the type of land that you are monitoring, and this is very useful for energy projects to know where they can deploy the projects in a more efficient way. For example, to know how much energy they can generate, to know if there is an impact on the environment where they are located, to know if their infrastructures are around. So it provides really very valuable information that currently is underused because energy companies are not so much aware of the capabilities of space and what can it offer.
And can you go into more detail on the Copernicus program? What sort of data is available specifically?
So Copernicus is the particular Earth observation program of the European Union. It's an Earth observation. Basically, it's a technology that's also called remote sensing, in which you can monitor remotely what's happening on the surface of the Earth, on the atmosphere, as well as water bodies. So Copernicus, in particular, is a set of satellites called the Sentinels, which provide, and they orbit around the Earth, and they provide data on a regular basis. They are also complemented by a component that's called in situ sensors that are distributed on the Earth, and as well as another component that they are the Copernicus services. And these Copernicus services are basically thematic information that make use of the satellite data that is being collected, as well as the sensors, and they provide the information about the land, about marine information, about atmosphere. There is also security and emergency services for dedicated actors. So the Copernicus program per se, it's a civil program. It's funded by taxpayers' money, and what we are trying here, what makes Copernicus special, let's say, is that all this data is open and free. So everybody can use the data. All European companies, citizens can use the data and can benefit from it. So our main role is to promote the usage of this data and try to bridge, let's say, from energy companies to make them understand how can they use the data and how this data can solve some of their challenges, but as well to, let's say, space technology companies to explain them or make them understand what are the needs from the sector, particular sector, and how can they build solutions that are really solving problems that the energy sector have rather than just technology per se.
And can you go into more detail on some of the energy sector problems that the data is being applied to?
Yes, so this analysis that we have been doing, and together with the energy actors, because one of the process that we do is, as I said, collecting user requirements and then informing the sector, and the most prominent or potential applications where space data and Copernicus can help is on, for example, on site selection, as I mentioned before. With Copernicus, you can have information about land use, land cover. You can have information about the environment. So in order to do environmental impact assessments of where the solar plants or wind plants can be located. It can give you as well information on the potential energy that could be generated, because through satellite data you can monitor the amount of radiation, solar radiation that is generated, and you can have this information. This is also important because you can have it historically. So it's not only what is happening right now, but it's also this information is stored historically. So you can have information from and see the trends that have been happening in the previous years, and as well do projections. And now this is very critical with climate change, because you need to take into account not only historical information but also climate change information, because you cannot just directly predict what's going to happen just looking at the past, but also doing some modeling for the future. And this information is critical. We have worked with some providers to do some proof of concept. For example, this is something that we do. We also fund innovation projects within Horizon Europe. And one of the projects we did, it was forecasting of solar power with a very short timeline of 15 minutes. So, and the accuracy of that prediction is very critical for energy companies, that they are selling the energy in the market, because if they mistake, if for example there is a cloud coming and they didn't foresee that, the energy that they predicted is completely different, and they can get penalties. They can get curtailment, and any amount of degree of accuracy that you get in the prediction is crucial.
This is where I'd like to bring you in, Fernando, as representing the BlueX project. And can you tell us a little bit about the project and how it's been using space data?
Hi, Jonathan, and thank you for the invitation. Well, BlueX stands for Blue Energy Offshore Installation Accelerator, and is an innovative Earth observation-based solution designed to optimize blue renewable energy. In the BlueX, 7 countries, 7 European partners work closely together in different countries: Portugal, France, Italy, United Kingdom, Netherlands, and also Germany. It provides access to tailored satellite-based data covering oceanographic, atmospheric, and environmental parameters to meet diverse needs across target energy types. These energy types include floating, solar, offshore wind, wave, and tidal. BlueX supports decision-making throughout the entire life cycle of blue energy installations, from site assessment and operational management, and also for the decommissioning stage. The core development of this project is a web-based tool, a decision support tool, and also an immersive XR tool, where relevant datasets are integrated and easily accessible. The tool includes advanced data analytics, enabling users to leverage satellite data for trend analysis during site assessment, or access near real-time data for safe operational planning. Also, let's say the key benefits of this tool are fast and easily access to high-quality data, tailored information to meet specific needs, data-driven support for regulatory compliance, reduced risks and operational costs, and also a full scalable via API integration. Also, we are developing a multi-user XR tool, it's an extended reality tool that supports smartphones, VR headsets, such as Apple Vision Pro or Meta Quest, etc., for planning, for visualization, and for monitoring those stages in the offshore blue energy projects. We are developing 2 demo apps regarding this XR tool, one for immersive monitoring of tidal and wind corridors, and the other one for training and qualification, let's say it, for catastrophe scenarios with XR using an oil spill scenario.
And have you experienced any specific challenges in using space data?
Yeah, we are currently in the testing phase, so the information gathered so far should be considered preliminary. During the user consolidation phase and throughout the discussion with the stakeholders and the end users, we identified a strong demand for high-resolution offshore data, which we are able to provide. Preliminary feedback showed that the datasets and the functionalities will be very, very beneficial for different purposes.
And what final outcomes are expected from BlueX?
Yeah. The final outcome, well, the satellite-based information will be delivered throughout a web application, as I mentioned, as a decision support tool. The web app will be accessible via any standard internet browser without restrictions, and additional functionalities defined during a dedicated user consolidation phase at the start of the project will enable further analysis of the datasets. Integration with various business applications will support multiple aspects of accelerating offshore installation processes. We can also deliver the XR tools to help on that decision support with our smartphones or tablets or VR headsets to, as I mentioned, to catastrophe scenarios, understanding and drawing what we call the what-if scenarios, and also to monitoring and understand what is happening in a real environment, such as offshore wind farms, without the need to be there in the middle of the ocean.
And going back to you, Eduard, how can companies access space data?
So there are different platforms and even commercial platforms where particularly Copernicus data is available because it's being open and free. You can access from many places. Then the official places where the data is available. Let's say the easiest way, the most user-friendly way, would be the Copernicus services platforms themselves. That they have their the data stores where data can be. It's easier to understand than to download. This data is already ready to use, and the information is more understandable and actionable. But of course, there is the data coming directly from the satellites, what we call the raw data, that can be accessed directly through what we call the Copernicus Data Space Ecosystem. This is a platform that is funded by the European Commission, and it gives access to all the data. Of course, this data is more scientific, so in its good experience to know how to get the data, how to understand it, and how to process it. But is there available as well? As well, we're improving always the platform. So also through this CDSC platform, the Copernicus Data Space Ecosystem, more data directly from the services will be incorporated. But as well, many of the companies that we have been working with, they opt to go directly to specialized service providers, the ones that are knowledgeable in Earth observation. They know how to get the data, they know how to process it, and they know how to produce information that is actually relevant for them. So they kind of have a man in the middle that they provide the service for them, rather than having to be experts in Earth observation and having to download the data themselves. But the options are quite wide, and as I said, there are multiple platforms where it can be downloaded.
And are there new satellites in development and potential new sources of data in prospect?
Well, the program is in constant evolution, as you can imagine. We have now the Sentinel missions, as I said, that is how the satellites are called, which each of them, they provide different types of information and data. They have different sensors on board, and we're launching new satellites to increment the number of satellites that are there, so more data it's provided. But as well, there is a plan to expand these two new missions. They're called expansion missions, with new capabilities. For example, high-pace spectral data that can allow you to detect different materials, different types of vegetation. There is new thermal sensors, which allows you to detect the amount of heat that is being produced by the different materials with a reflection. But as well, I focus on Earth observation because it's the one that provides the more value. But also in terms of new satellites, we're working. The European Union is working on a new constellation of satellite communication infrastructure, which will complement the Earth observation and the positioning one, which we believe will be also great for innovating and will complement all the ground-based communication systems that we have. And it will be mostly used for remote areas, but also to serve as that backup or for critical infrastructures, such as the ones that are needed for the energy sector.
And when will that be available, or when are the satellites going to be launched?
So the new Sentinel missions, they will start. There is a plan from now to 2035. So they will be gradually, and they are being developed right now. And similarly for the satellite communication. So now it's being in development. So this is a collaboration as well with member state capacities and will be put in place. But of course, with the let's say geopolitical situation, the need for more resilience, we have to try to be fast and put this as soon as possible. Also to strengthen the competitiveness of the European space sector.
What's the first step to start exploring this data, and how can USPA help in that process?
Thanks for the question. That's why we're here at Enlit as well, because we want to tell companies how they can use the data. As USPA, we want to facilitate. We raise awareness. We fund proof of concepts. We also publish use cases and success stories. And as well, we recently published a guidelines document, so how to use Copernicus in the energy sector, which is basically summarizing in an easy to understand way for energy companies how can they get access to the data, where can they access the data, and as well for what they can use the data in their daily operations, let's say. So this, of course, they can access USPA website and see all the use cases and all the publications that we have there. As well, there is a dedicated energy hub with Copernicus has put in place, which it's trying to put together a repository of all the products and services of Copernicus that can be beneficial for the energy sector, and also has another compilation of different use cases. But as well, if anybody is interested and wants to know more, they can also contact us. Me particularly, that I'm the one responsible for the energy sector, and we can go through everything what is available, and we are always open to discuss with users. That's mostly what we do, to understand the users and to explain them how to use the data. So first, understand what is there, what has been done. If you see that you have an opportunity to have a project with us, to work with us, contact us directly as well.
Okay, good. Well, thank you very much for your insights, Eduard, Fernando. And for more insights, join the Enlit community.